This is the video instruction for lesson 12.4. You should be using a pencil. Please make sure you have a pencil to complete your notes. And we do have 3 vocabulary items that I'd like to go over with you. Before you do the vocabulary, please write down the learning target. And at the end of this lesson, you should be able to find the probabilities of compound events. So that leads us to our first vocabulary word. The union or intersection of 2 events is called a compound event. So when we have an intersection of 2 events, that means that they can cross over. You know, they have some point that they are similar. So compound event, union or intersection of 2 events, meaning rolling a die and spinning a spinner, or 2 events like drawing a certain card out of a deck that might meet 2 different categories. So it could be a certain suit of the deck of cards, or it could be a certain color of the deck of cards, or it might be both. So that's what we mean by intersection. And then the next vocabulary is overlapping. 2 events are overlapping if they have one or more outcomes in common. So if they have at least one outcome in common, then there is some sort of overlap. And we'll talk about how to determine the probability of a situation where you do have an overlap. The last vocabulary says 2 events are disjoint, or another word for that would be mutually exclusive. They don't have anything in common. They have no outcomes in common. So 2 events are disjoint if they have no outcomes in common. Let's go ahead and take a look at our first example. Example number 1 asks us to find probability of disjoint events. And remember, disjoint events are those that have no outcomes in common. So we do not have to do anything about an overlap because they have nothing in common. So the situation is such that it says a card is randomly drawn from a standard deck of 52 cards. So 52 cards, you should know that there are 4 suits. Okay, the suits are hearts, spades, and diamonds. Those are the red ones there. And then the black ones are going to be spades. I should have drawn that. And whoops, can't draw that really great. And then, of course, clubs. Okay, those are the 4 suits. And then, of course, each suit has 13 cards in it. So there are 13 hearts, there are 13 diamonds, there are 13 spades and 13 clubs, and that's a total of 52. And remember, each suit has a jack, a queen, a king, and 1 through 10 in terms of the cards that they have. So now the question is, what is the probability that the card that you pull out is a 5 or an ace? Okay, so how many 5s are there in a deck of 52 cards? 5s you have a chance of pulling out a 5 4 out of 52 times, because there are a total of 52 cards and there are 4 5s in the entire deck. So the probability of pulling a 5 is 4 out of 52. Well, what's the probability of pulling an ace? Okay, the probability of pulling an ace is going to be the same because there are still 4 aces in the deck of 52. Now, these don't have anything to do with each other, right? A 5 cannot be an ace cannot be a 5, so there's no overlap. So in this case, what I'd like you to do is take the probability of a certain event and the probability of another event and add them together, because that's going to be the probability of either one of them, either one, a 5 or an ace, being drawn. So if we add those 2 together, 4 over 52 plus 4 over 52, we end up with 8 over 52, and that can be reduced if you use 2 as a common factor of both 8 and 52. 2 goes into 8. I'm sorry, let's use a bigger number. 4 goes into 8 2 times, and 4 goes into 52 13 times. So here's our final answer. The probability of pulling a 5 or an ace is 2 out of 13 because we've reduced our fraction. So you'll want to make sure that you reduce all of your fractions when you have something that is reducible. And this formula right here, this equation, is going to be important, and you may want to remember this as the OR equation, or formula, because remember, the word OR means one or the other of the two things could be happening. So that's why we're adding them together. There's a wider selection of things that could happen if we use the word OR. If we use the word AND, then that means that there has to be some overlap. All right, let's take a look at the next example. Example number 2 says find the probability of overlapping events. So that means that they have something in common. A card is randomly selected from a standard deck of 52 cards. What is the probability that it is a club or a 3? Well, we know that there are 13 clubs total, and we know that one of those clubs is a 3. So we know that there's some overlap, all right? Well, let's take a look at, if we drew a Venn diagram, we would have over here, let's say that this is the chance of drawing a club, and over here is the chance of drawing a 3. There's one card in the middle here. There's a chance of drawing a club that is a 3. The 3 of clubs is both a club and a 3. So we could say that there is the 3 of hearts, right? There's the 3 of diamonds, and there's the 3 of spades. And then, of course, all of the clubs, 1, well, ace, 2, 4, 5, 6, 7, 8, etc. So you can see, and then we have jack, queen, king also. And the only thing that is the same for both groups is that 3 of clubs. So I should probably draw, this is the 3 of clubs. That's not a really great picture of a club, but you can get the idea. So, all right, let's write down the probability of drawing a club. So P, probability of drawing a club, is going to be 13 cards out of 52. And the probability of drawing a 3 out of a deck of 52 cards is only 4, because remember, there are 4 cards that have a 3 on them. So what is the probability of drawing a club and a 3? There was just one card out of 52 that is a 3 and a club. Remember, this is showing us that there's one thing that they have in common. The two events have one thing in common. So what we're going to do is we're going to add all of them together, right? This is the chance of or, a club or a 3, but then we need to subtract the overlap. So subtract the overlap just means that we're going to subtract what they have in common, because you can't count that card twice. You cannot count the card in the clubs and the 3s if it's both. Okay, so we're going to have to get rid of one of them. All right, so what is 13 over 52 plus 4 over 52 minus the overlap, 1 over 52? Now we have all common denominators. 13 plus 4 is 17, minus 1 is 16, so 16 over 52. And it looks like, again, we can use 4 as a common factor of 16 and 52. So if I divide this by 4 and divide this by 4, I'm going to reduce my fraction to 4 over 13. Okay, so the important idea of this example is that we understand what an overlap is, and that we need to subtract the overlap after we figure out the individual probabilities of both of these events, drawing a club and the probability of drawing a 3. All right, so we have one more example here to take a look at. Example 3 says use a formula to find the probability of A and B taking place. Now A and B would be considered the overlap. Okay, if if something has both the characteristics of A and the characteristics of B, then that would be considered the overlap, and that's what we have to subtract. All right, so we already know that this formula, you may not have known it formally, but I'd like you to write it down here, and we're going to use it in the future as well. Go ahead and write down the probability of A or B taking place equals the probability of A plus the probability of B minus the overlap, and we're calling the overlap probability of A and B. So this is our probability of both things in one. All right, and we already know the numbers. It tells us right here that the probability of A taking place is 0.3, and the probability of B taking place is 0.72, and then it tells us that the probability of A or B taking place is 0.6. Okay, so again, I want you to make sure that you realize that this formula is going to be important. If I do give you some problems that have decimals, those are the probabilities of an event taking place, you need to know that we're going to subtract the overlap. So the probability of A or B taking place equals the probability of A, which we have, plus the probability of B, and then you want to subtract the overlap. In this case, we don't know what the overlap is, and we're just going to give it a variable, and then we can go ahead and solve for it. So I'm going to combine the things that are alike. Well, everything on this side I'm going to combine together, and that's going to be equal to the 0.6. So I'm going to have 1.02 minus x. I don't know what the overlap is. That's what I'm trying to find out. Equals 0.6. So to find out what x is, I'm going to have to subtract 1.02 from both sides. And that is going to give me, on the left I'm going to have negative 0.42 equals, and this is canceled now, so I'm just going to have a negative x over there. And when we have a negative x and a negative 0.42, so we have a negative result on both sides, I can multiply both sides by -1, and that basically gets rid of the negative sign, so therefore x is going to be equal to 0.42. That is the amount of the overlap, or the probability of A and B. That's the overlap. All right, the last thing on the front side of this page is the on your own questions. I would like you to think about the first three problems that we did on this page. These are going to be very similar to that. Number one here asks you to find the probability of selecting a queen or a 4. Now just a reminder, this is going to be disjoint. There is nothing similar on a card that is a queen or a 4. Those are two different cards. They can't have anything in common. Number two, selecting a spade or a 5. Well, just remember, there is one card in the deck of 52 that is a spade and a 5. So you're going to have to subtract the overlap in this particular problem. And for number 3, it says find the overlap when you know what the other things are. So go back to example 3 and find that formula that we were looking at. Okay, so the formula that I'm speaking of is this one here. All right, let's go to the second page, the back side, so that you can look at the other examples in this video. All right, so example 4 is asking us to find probabilities of complements. Complement is another vocabulary word that you do have on your green term sheet, but we did not include it on today's lesson. A complement is the idea that something would not happen. It's the opposite of the probability. So when two 6-sided dice are rolled, there are 36 possible outcomes, and you wrote all of those 36 possible outcomes on that green term sheet. This is also, there's a picture of this on page 833 in your textbook, so you can take a look at that. So we want to find the probability of the given event. So the first event says, what is the probability that you're going to roll 2 die, and the sum of those 2 die is going to be less than or equal to 3. There are only 3 events that could take place, 3 outcomes. If we have 2 die The first one could have 1 dot, the second one could have 2 dots. Then we could also have another scenario where let's say each one of them just has a single dot, right? That's another possible outcome. And then the other possible outcome is that the first die had 2 dots and the second die had 1 dot. Okay, so even though those look the same, these two rolls would look similar, they are actually counted as 2 separate rolls, all right, or 2 separate possible outcomes. So it looks like to me we have 3 outcomes out of 36 that could take place, right? That's the probability of having a sum on the dice of less than or equal to 3. All right, and we can reduce that 3 over 36 because both numbers have a common factor of 3, so I could reduce this to be 1 over 12. So the probability of rolling 2 die and getting the sum to be equal to 3 or less than 3 is 1 out of 12. All right, well, let's take a look at B then. B in this example asks us to find the sum that is greater than 3. How many, or what's the probability of rolling 2 die and getting the sum that is greater than 3? Well, that's the opposite of what we just looked at. So the opposite of what we just looked at means that there has to be 33 out of 36, right? Because we said that there were only 3 of the 36 that would be equal to 3 or less than that. So that means that everything else would be greater than 3. All right, so this is called the complement. The complement is the opposite of the probability that we were just looking at. So we could say that this is going to reduce to 11/12. You always want to reduce the fraction that you have in terms of the probability fraction, so I can divide 3 into 33 and get 11, and divide 3 into 36 and get 12. So if you notice here, these two fractions would add up to 12/12. 11/12 plus 1/12 equals 12/12, and that means that we have accounted for all of the outcomes if we get to 1. 1 is also equal to 100% chance that either the sum is greater than 3 or the sum is less than or equal to 3. Now these things can be a little bit confusing. If that didn't make sense to you, please rewind and watch example 4 again. And then of course if you need some additional assistance, please ask in class. Let's take a look at our last example. It says use a complement in real life. So we have an annual salary problem, and a university conducted a national research study of recipients of PhD degrees. That means that you're a doctor of some study. From the research data, the university determined that the probability that these recipients had annual salaries in excess of $95,000 was 0.834. So most people who have a PhD earn more than $95,000. So the probability that a person with a PhD has more than $95,000 of their salary as a salary is equal to 0.834. So the closer you get to 1, that means, there's a bigger chance that those people will have a greater salary than $95,000. So to find the complement, we just have to take the probability of that happening and subtract it from the number 1. So the probability of someone having less than or equal to a salary of $95,000 is equal to 1 minus the probability of someone actually getting that salary. Okay, so see what I did is I took the probability and I put it into the formula. We're subtracting it from 1, which is 100% chance that one of these two things takes place. And then the probability of someone earning less than or equal to 95,000 would be 0.166. And I can translate that into 16.6% of the population of PhD folks earn equal to or less than 95,000. The majority of people who have a PhD, though, that's 83.4%, earn greater than or more than $95,000 per year. So PhD degrees generally are, between 12 years and 15 years of study to earn your PhD. So I guess if you go to college for that long, it's nice that you get a pretty decent salary. There are some questions here at the bottom having to deal with complement. If you take a look at this notation, that means complement when you see that bar over top. So probability of A complement, the complement of A taking place. So for each one of these, all you're doing is subtracting the probability from 1. So for number 4, let's just take a look at that one real quick. To the probability of A bar, that's what you say, A bar, equals 1 minus 0.63. Okay, so you're just subtracting the probability from 1. And if you need any help with those, please ask in class. Thank you for watching.